Hello everyone, and thank you very much for joining me today. My name is Nir Schachter and I'm a product manager at Redis Labs, and today I'm going to speak to you about how to automate Redis Enterprise Cloud using infrastructure as a code with HashiCorp Terraform. I'm going to start with a quick introduction of myself, then we're going to do an overview of Redis Enterprise Cloud, going to speak about the challenge that cloud developers have and how infrastructure as a code solves it. What is infrastructure as a code, of course? We're going to speak about what is Terraform, what it is used for, and then we're going to jump right into a live demo where I'm going to configure a Redis Enterprise Cloud subscription and an AWS VPC and a host, and how we're going to pair them together, everything with Terraform, of course. So a little bit about myself. I come from a technical background. I graduated computer science from ITC Herzliya. I then went on and started to work as a software developer and a team leader in a company in Israel. Then I moved to the sales side and working as a pre-sales engineer at Cisco. I then did my MBA at Columbia University in New York, which after I started to work as a product manager in AWS in a product called API Gateway. And today I'm a product manager at Redis Labs in charge of our cloud product. So as you can see, I have a very diverse background and I like to experiment all the different sides of the tech industry. And I really enjoy it so far, so hopefully I'll keep on learning in my career. So let's do an overview of Redis Enterprise Cloud. And by this point, if you are here today, I assume that you know what is Redis Enterprise, but just so we can cover it, Redis Enterprise is a product made by Redis Labs, and it's made for customers who need more from the Redis open source product. And by more, what I mean is stuff like our modules to extend the data structures that you can work with, stuff like Redis JSON, Redis Graph, Redis Search for extensive search capabilities and secondary indexes, Redis AI for AI computations on the Redis instance as close as possible to the source. Additionally, you can do stuff like active-active for customers who need high availability or geo-distributed databases. And Redis Enterprise Cloud is basically Redis Enterprise in the cloud. It's a fully managed database as a service product. And what we do is basically we offload all of the database operations from our customers and we provide them with an endpoint that they can then point their application to read and write from that endpoint to their database. We also offer multi-tenancy model, which creates a very efficient TCO model. We keep all of the Redis core values also in our cloud products. First and foremost, the speed, so you can run sub-millisecond latency at the infinite scale of the cloud. We offer 5 nines availability with our active-active, and keep an eye out for a session by our CTO Iftach about active-active in the cloud. Of course, we offer this service across the 3 major cloud providers, GCP, Azure, and AWS. So this is very quickly about Redis Enterprise Cloud. Now let's talk about the challenge for cloud developers. And I took this part out of a link I found in the internet, and you can see this link in the resources slide later on. But basically a long time ago in the data center world, it was ruled by sysadmins who used to deploy all the infrastructure manually. So every server, every route table, every database, every load balancer, everything was created and managed by hand. And this created problems because there was mistakes made by people, so accidental misconfigurations. No one knew exactly what's going on in those infrastructure, in those environments. And God forbid if the sysadmin left for a vacation or even left the company, no one knew how to handle it. Let's take, for example, a big company who has a website, and they have a production environment for that website, and they have multiple development teams working on this website. The first development team working on one part of the website, second development team working on a different side of the website, and so on and so on. So you had to replicate your environment for each of those development teams and make it similar to your production environment. And this is where things got out of hand, because if you had to make a change for a configuration in your production environment, let's say you had to change your AMI for one of your EC2 hosts, you had to remember to replicate this step across all of the different environments. And that was a problem. Thankfully, DevOps came into the world, and with it, infrastructure as a code. Maybe it was vice versa, I don't really know. But infrastructure as a code basically automates the entire provisioning and deployment process, and it represents your infrastructure in a code file, which anyone can read and immediately understand what you have in your environment, what's the state of everything. Like any other code solution, you can then store those files in a versioning control, you can debug them, and you can do different stuff. And most importantly, you can create reusable and documented infrastructure templates that you can then, like the example I gave with the development team, you can replicate it very easily without even thinking about it. So this is infrastructure as a code. What is Terraform? So infrastructure as a code is a concept. Terraform is a tool that implements this concept. There are many tools. What's great about Terraform is that it has multiple providers, many providers of all the popular infrastructure services that you work with, including Redis Enterprise Cloud and AWS, and you can mix and match those providers in the same configuration file. So you can have your whole application from across different providers in the same configuration file. It's declaratively defined infrastructure, so you can see everything that you have in your environment, and you can see the state of those resources. Another cool thing about Terraform is that it allows you to create an execution plan, so you can see exactly what is changing, what need to be removed, what is going to be added before you apply your changes, and we will see this in the demo right away. So this is Terraform very shortly. Now let's jump right into the demo. So as I mentioned, I'm going to configure a Redis Enterprise Cloud subscription and AWS environment, and we're going to create a VPC peering between those. So let's get right into it. And what you see here is this is a VS Code. It's very comfortable to work with because you have these extensions, and if you look for Terraform, you have this official extension from HashiCorp Terraform. I already installed it, but you can install it in one click, and then you can start working on your Terraform files, and you'll have autocomplete and errors that are relevant, which make it really comfortable to work with. So the first thing that we need to do when we start working with Terraform is we need to declare the providers that we are going to use. So you can see here, these are the providers that we're going to use, AWS and Redis Cloud. Once we declare those providers, we're going to do a Terraform init. And this basically pulls all the providers that you declared, installs them, and allows you to work with those providers. In my example, you'll see that I already installed those providers, so it's going to be reusing those, but even if you haven't before, it's going to download and install them, and at the end you'll get the same state. We will see it in a minute, that Terraform has been initialized successfully, and that you are ready to provision your resource, as you can see here. So first thing that you'll see here, a lot of variables, because there's a lot of data in this template that I cannot share with you guys, so I put it in variables. I later on will show you how we work with the variables. That's the first thing. And we're going to start by creating our first resource, which is an AWS VPC. You can search the web for everything. You just do Terraform and then the name of this resource, AWS VPC, and you'll get exactly how you need to configure those. For VPC, you only need to give an argument of the CIDR block. Basically, a resource in Terraform is configured by the word resource, the resource type, and then you give it a resource name, which you can later on reference in your template, and we will show this in a moment. So we create first our VPC with this CIDR block. The next step would be to create a subnet in that VPC. And how we reference the subnet in the VPC is that's another cool thing about Terraform, is that you are able to reference resources that you declared. At this point, nothing here is created, but you can still declare, use those and reference those in other resources. So Terraform will know that it needs first to create this resource, and only then it will be able to reference this ID. Every resource comes with the ID argument, even if you didn't declare it, but you can also reference the other arguments. So this is the idea of the VPC. And here I'm going to show you how we're using variables. So for the CIDR block for the subnet, I used it as a variable. Terraform will always look for a file called terraform.tfvars. I created here an additional files. You can see this is all of the variables that I'm going to use. And in this case, the subnet prefix is 10.0.1.0/24. And once we create it and we're going to look in the AWS console, you'll see that it's applied here and in this variable. We're giving it an availability zone, US East 1A, and a name. Those names will be the names that we'll see later on in the AWS console. Next thing that we're going to create is an AWS network interface. And again, we are referencing the subnet ID like we did before with the VPC. I'm going to give it a private IP. You can give it a list of IPs, but in this case, I'm just going to use this one IP, 10.0.1.50. And the next step is that we are going to create an AWS instance, an EC2. You can see that the first thing I'm doing is assigning an AMI for that instance. I'm hard coding here the AMI code, but you don't need to do that. There are multiple ways that you can make this more dynamic. I'm just not going to cover it in this session. Same goes for the instance type. I'm using the T2 micro here because it's the free tier instance. If you can use here whatever you want, of course. Availability zone, we want to keep the consistency with all of our resources. And now we're going to attach the network interface that we created here. And this is basically what's going to put this AWS instance in the VPC that we created. And again, we're giving it a name, RedisConf instance. We're going to see this later on in the AWS console. So this is all the stuff that we did on the AWS side. We created one VPC, one subnet, one network interface card, and one instance all tied together. And now we're going to move to the Redis Cloud side. So here I'm going to start by using a data resource. The difference between data resource and a resource is that the data resource is not actually created anywhere, but you can then reference it later on in your template. Before you start working with Terraform with Redis Enterprise Cloud, you first need to manually register in our website and provide the payment method, and then you should reference it here. Again, the last 4 digits of our card number is in a variable, but you can use your own here. Another cool thing about Terraform is this resource called random password, which allows you to generate random passwords. You can give it the amount of passwords that you need and then the rules that you want the password to include, and it will just generate passwords for you. And we're going to use this later on when we create our databases inside the subscription. So once we declare the payment method and the passwords, we can go ahead and create our Redis subscription. So this is the resource and the name that we gave it. This name is going to show in the Redis console. And pay attention, this cannot be changed. All of the rest of the arguments can be changed, but this one can't. Going to reference the payment ID that we declared earlier. And we're going to declare the memory storage type. This defaults to RAM, so you don't need to insert it, but just wanted to show you guys. You can use your Flash as well. And now we're going to specify which cloud provider we want this created into. Pay attention, we are still inside the Redis subscription resource. So for the provider, we're going to reference AWS. We want this created in AWS. I'm going to provide here a cloud account ID. This defaults to 1. You don't need to specify it. And then you are going to use the Redis Labs resources. We're going to specify the region that we want, the CIDR block, and availability zone like we did before. And now we can start creating our actual databases. In this case, we're going to create 2 databases. The first one is Redis JSON, protocol Redis, memory limit of 1 gig, replication, which is basically high availability true, and no data persistence for this database. We're going to size it by operations per second. So for this database, we want 26,000 ops per second. And we're going to use for the password the first result of the password generated that we used before. Second database, we're going to call it Redis DB JSON. Same memory limit, same for replication. In this case, we are going to use data persistence and the file every 1 second. And we're going to attach it a module. In this case, we are using Redis JSON, but you can use any module that you want. Again, for the ops per second, we're going to use 10,000 in this case. And we're going to use the second result from our password generator. Once we created the subscription, it ends here and the database inside of it. We want to now start to peer those together with our VPC, with our AWS environment that we created. And for this, we have this resource, Redis Cloud Subscription Peering. First, we are going to reference the subscription that we created, the region, the AWS account ID. In my case, again, this will be in a variable. You can use your own AWS account ID. We're going to use the VPC ID that we created before, and here you can see that we are also referencing an argument from that VPC, so we don't need to repeat it here. Last thing is just to create the resource plan. Last thing is to declare the peering connection acceptor. We're going to use this to attach it to our subscription, to our peering connection, and now we can just do a Terraform plan, and this will show us exactly what is going to change. At this point, none of these resources is created, so we should expect that we will see only created resources here, and this will take a second. As you can see, all the green pluses are stuff that are going to be created. If I scroll to the top of this plan, you can see that we are only going to create. If we had also removed some stuff or change, we're going to have like a red minus for removals or a green tilde for changes. So you can always see what's going on. We are now just creating everything. So after we have this plan and we approve of it, we want to apply the changes. We'll do a Terraform apply. It's going to generate the plan again and then ask us to approve it. We're going to do yes once we are prompted for it. This takes a couple of seconds. In the meanwhile, oh, here it is. So I'm going to do yes. And now it's going to start and provision all of the resources that we declared in the different providers. At this point, I'm going to stop the video. This takes several minutes, and we're going to come back once everything is created. Okay, great. So we are back, and as you can see, we have successfully created 9 resources. And let's go ahead and to the different consoles and check it out. So first, let's go to the AWS console, and let's go to the EC2 dashboard. We can see here, here is the instance that we created, the RedisConf instance. If I click on it, you can see that it's assigned the private IP address that we gave the NIC. Let's go ahead and look for the VPC that we created. Here is the VPC, RedisConf prod VPC, and this is the VPC that we created. We can also look for the subnets that we created. Here is the RedisConf prod subnet. As you can see, it's 10.0.1.24, the value that we took from our variable. And everything here on the AWS side has been created. Let's move on to the Redis side. So I'm going to log in. Let's go to the subscriptions. This is the RedisConf demo subscription that we created. You can see the total charge for it. You can see in the security that we created the VPC peering, and the peer is established. So we also did something that really saves time from our people. Think about replicating this hundreds of times, and also make sure that you don't make mistakes in the configuration, that you don't need to remember every single configuration you did every time you configure. You just replicate the template. So going back to the presentation, this is the last slide, some resources that I put here, a comprehensive guide to Terraform. This is the link for the official Redis Enterprise Cloud provider in Terraform and all of the documentation you need to work with it. This is a guide made by one of our product directors, Aviad, who also led the creation of this Terraform module, and shows you what you need to do to configure Redis Enterprise Cloud subscription. And this is a great video on how to work with Terraform. So thank you very much for joining and listening. I hope you enjoyed it. And if you have any questions or inquiries, feel free to reach out to me. You have my email here or down here below my image. So thank you.